Okay, and recording started. So, last time I actually have given you to like a task to create a calculator. Some of you already had a stab at it. Some of you actually have done a really good job and finished it. Um, and congratulations for all those who, you know, finished it, and congrats also for those who actually took a stab at it but didn't finish it until the end. You will see one solution, one of many. So here's how I would actually approach it. Also kind of note that, again, I'm not going to handle all the edge cases. There are many edge cases you need to handle to make this much better calculator. However, I'm going to solve the heart of the problem, which is how to create a calculator that is actually functioning, right? The core functionalities, the things which a majority of people like got stuck on. This is my objective. So I'm gonna hit here FRM. In naming functions, right now I've seen people like when they name their forms and name their controls, they don't name them appropriately that much. So I'm going to show you the appropriate way of doing this, at least in Windows Forms. By the standard, we use something which is called the Hungarian notation. And the Hungarian notation implies that you name the type, you create an acronym of the type, and then the type comes afterwards, or the name of the type. So for example, here is going to be FRM calculator. So this is a form, and I'm going to say yes because I would like to rename not only the name of the file, but the classes as well. So I'm going to yes, please refactor that for me. Now, FRM is the shorthand for the form, and this is like the 3-letter acronym to denote that this is a form, and then the name of the form, like we called it a calculator, right? And if I hit F4 here, this is going to be fit calculator, okay? I'm going to actually make this a little bit smaller just to fit in the theme. And I'm going to have a button at least, and I need at least a label because I would like to show what's happening in a buffer, because I'm going to have a buffer keeping the objects in, or keeping the state of the memory, what's happening in the memory in there, just for us to debug things and to look at stuff. And at least a text box. Now, a text box is going to have txt output. So this is my output. And as you can see here, text box, I acronymed it to a txt. Just to make things complete, usually form is FRM, usually, unless your team specifies otherwise, but this is the most common. LBL, I think checkbox is CHK. I think progress var was PRG, I think, or I think it's both PRG. Radio button is it was actually RD or RDB, depends on how your team names it. A button, usually people call it BTN. Let me see here, combo box is CMB. List box, I don't know if we're going to use it in this semester, but yeah, LST, I think. Picture box was actually PB or PCB, depending on what team you are working on. Rich text box was I think RT or RTX or RTB, depending on whom you worked with. Tooltip, I think it was TT, I think. TreeView is TV, and that's it. These are the stuff which you... datetime picker, which you're going to see. Datetime picker, we call it DTP. Okay, so these are the major ones which we usually use, right? And the rest is usually being agreed with the team. So these are the acronyms we use before naming the variables, because it's much easier to recognize them in code. And it's only happening in Windows Forms, by the way. All right, so let me go ahead and use the button. And it's going to be BTN. Actually, I don't need to name that button because I don't care pretty much about the name of the numbers. I care only about the numbers themselves. So I'm gonna actually make the size a 64 by 64. So it's like a square button. And I'm gonna actually like duplicate this thing. So Control C, Control V. And also for the operation. So we have the 3 numbers and then the operation. And then I'm gonna copy and paste this guy like so. So we have, and also one more row, because we need a decimal point and an equal and stuff like that. The text box, we need to have it. First of all, the numbers are appearing from right to left, so we're gonna have to say yes, because I would like the numbers to come from this side. Second thing, I would like to make the font bigger. So I'm gonna have the font, let's say around, I don't know, like 30 or something. I'm gonna scale this boy up like so. Now, obviously you can do some limitations like, hey, you cannot add, you cannot have, you cannot have more characters than what you are allowed to, etc., etc. Label 1 is not going to have any text because this is going to be the display of the buffer itself. So I'm going to call this LBL buffer. Probably I missed it in the, did I? Nope, I didn't. Okay. So LBL buffer. And this guy is going to be TXT output. And then we have the numbers, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I'm just going to name those in that way. Only the text. I don't care about the name of the button. So 1, 2, 3, 5, 6, 7, 8, and 9. And right now we have like addition, substitution, multiplication, and division. And what we could do, if we go to the character map, you could in fact search for these signatures or these signs. So you could say, give me all the, I can add, for example, division. And division will actually give me the signature of the division. So I can actually grab that. And I can go ahead here and put that into the text. And I can call this BTN because I need the operations. I need to know the name of the buttons. Right now, I'm going to address them. BTN division, right? So we said multiplications. I'm going to have here multiplication. I'm going to reset that. And I'm going to grab that X. And that X is kind of special. Apparently, it's not the same as the X. So I'm going to put the text, put BTN multiplication. What else do we have? So division, multiplication, subtraction, which is a dash probably, subtraction. Subtract. Yeah, probably doesn't exist because it's just a simple dash. So yeah, there's no specific thing for it. And this guy is going to be BTN subtraction. And we finally have addition, right? So BTN addition, which I think also doesn't have any one. So addition is going to be just a simple plus, which, oh wow, I cannot type today. What the addition? Oh, okay, anyway, simple plus it is. So there we go. And this is simple plus. Now we have a decimal point and then we have an equal, right? So what I could do is just simply put the equal in the bottom just to balance things out. So I'm going to put the 0 a little bit bigger. So this is going to be 0. And this is going to be decimal point. Okay. And this is my, let me just increase this just a tiny bit because it annoys me that it's not aligned. And right there, I'm just going to put a nice gigantic equal sign. So here. equal. Okay. Now, obviously, these fonts are kind of small, so I'm just going to grab them all. I'm going to make the font a tad bigger, like 30 or something like that. Okay, so I think this is much better, I think. Maybe even I will increase the font on this guy. So this font of this guy is going to be, what, 32 maybe? Oh, actually, let it be 40, I think. There we go. So, so right now we have a bigger number. So if I actually type in some text, we get a bigger text. Okay, good. Oh boy, I forgot. There's a label in there. That's why it was small. Sorry. Yeah, when you don't see these guys, just woohoo. Okay. Good thing that I remembered now. Okay. Yeah, I think this is it when it comes to preparing the UI. We are almost done. This guy is going to be btn equal though. We need it. So btn equals or equal. Addition, we have already added, subtraction, multiplication, division. Yeah, that's pretty much it. Now, here's the thing. Whenever I press a button, I would of these numbers and a decimal point, I would like actually to add them right here. I would like them to appear here, okay? And making them appear here, meaning that I need to make sure that I don't want to handle for every button. So imagine that you are like double click, and then you say txt output plus equals, then for example, 1, right? Some people like .text, obviously, because we need to add this there. So if I had Control F5, what I could do is just simply have 1, 1, 1, 1, 1s, right? And then people can start adding for every single button, right? Which is going to be a horrendous thing. Now, one of the things which another trick to solve this problem, because each one of them is actually having exactly the same behavior, I'm grabbing just the text on the button, and the text on that button will never change. So what I could do is just simply say, for every button, just do exactly the same event. However, how can I know which button it is? Now, in Microsoft Windows Forms, whenever you click on a button, an event is being raised, and it says also who raised that event, what button raised it, right? And right here, that button is in fact right hidden here. It's like casted into an object. So we need to cast it back into a button. Now, obviously, you could need to write a lot of guards like, am I casting the button? Is this casting to a button? If yes, then there are no errors. I'm actually, the whole thing is going to be functioning. If not, then you just simply, kill the program or kill whoever's trying to hack the code. So what you do here is, right now, I'm not going to do these additional checks, to be honest. All what I'm going to do is saying that I'm going to cast the sender, because again, whenever I click here, so on button click, that click will actually say, okay, that event has been raised, and Microsoft giving to me in the who actually sent that event. So here I can say var btn text equals to button, and then sender of text. And right now I grabbed whatever the text inside that button. And what I can do right now is just simply say txt output text equals plus equals that, right? And right now I'm going to rename this. I'm going to rename this to say buttons handler or number buttons handler. So whoever is actually clicking on that, whatever number button is actually being clicked, it has to go point to that event. So all of these buttons, right now this 0 is not pointing to that, so I'm going to actually make it pointing to this one. Okay, and you can do exactly the same thing for each one of those guys. So in fact, I can select all of those, and I say, please point to that one. So if I go ahead and hit F5, I can like say 1, 2, 3, 4, 5, 6, 7. You can type whatever number you want, right? So if I hit start again, if I hit actually 1 and then dot and then 1 and then another dot, we have a problem. We can actually add more dots in there. and we cannot allow this. So we need to detect if there is a dot has been added already. So now if somebody pressed the dot, we need to make sure it doesn't appear twice in the text or twice in the as a number. So I say if btn text equals to dot, okay? So if I'm actually adding a decimal dot right now, if this button has been clicked, which has a dot in it, right now I have to check, okay, if the txt.text.contains, so if I would like to say, if the text does not contain a dot, then just simply the text plus equals the dot. Otherwise, don't do anything. Just simply skip the whole thing and just simply add whatever number. So the main thing here is I'm having just a special case for the dot. If it is a dot, is inside that text box any dots? If there is one, just simply do not add it. If there is none, then just simply add it. So right now, if I have one dot, why do I have twice the dots? Hang on. Of course, it has to be else. Apologies. But else, yeah, happens to the best of us. So 1.3. Huh? Oh, it's plus equals. Damn, I actually like, today I'm missing. Yes, today has been a long day. So 1.2 and then point. You cannot add the point. However, you can add whatever number you want, but that point will never work again. Okay. All right. Sorry for the confusion there. So this is handling the buttons, like handling the numbers. Right now, you cannot do that. Now we have another problem, which is the calculation method itself. Now we need to grab whatever is inside that text box, parse it into a double, okay? And we are using doubles because they are a little bit larger in terms of range in memory, like in terms of whatever is after the decimal points, and it's also larger in terms of like how many numbers it can handle. So there are a couple of things I would like to keep track of. First of all, I would like to keep track of a buffer. So I'm going to have a private double buffer get and set. And then I'm going to actually assign it by default to not a number, not 0, not -1, not -2, because all these numbers are valid. I would like to make it just not a number. That means that this thing hasn't been populated yet. So I'm just putting it with something that nobody can use. That is not a number. You cannot operate on it. You cannot say not a number plus 1. I think it will actually break. Now here's the thing. Here's our problem right now. What I would like to do is I would like to be able to say 1 plus 2 minus 3 plus 2.5 divided by 3 and so on and so forth. Okay, so I would like actually to be able to do that. Now, in order for you to be able to do that, you need to say, okay, I will actually have 1, and then you hit the plus, and then you put 2. Now, the moment you hit minus, you need to make sure that this operation is done before you actually carry on with accepting more input. Now, there are many ways of solving this. Actually, our colleague here had actually solved it in a different way. Actually, like almost in a similar way, to be honest. Like he used arrays to push operations in. Here, I'm going to actually use stack. Now, here's the interesting part. You need to know what operations you have done. Now, in order for us to do an operation, what I'm going to do is create something which is called an enum. And an enum, which I think you already have seen in C++, is just this, by C# definition, it's called statically named integers. I think enums in C++ are more than what they are in C#. You can do crazy stuff with enums in C++, but in C# they are just simply, again, by definition, statically named integers, nothing more. So you can say enum, I'm going to call this operations, and I'm going to have here addition, subtraction, multiplication, division. There we go. It just simply like was smart enough to give to me stuff. And actually it's a type, by the way. I mean, this can actually live in a namespace on its own like this. Okay, obviously it has to be public because otherwise I will not be able to, it will be difficult to access. I mean, I can make it private, but it will be only within the namespace, I think. So right now I'm going to have a private stack. Probably I need to add the system.collections up there. Operations. I'm going to have a stack of operations. I'm going to call this operations stack, get and set. And I'm going to just import system.collection.generic. And I'm going to initialize that stack here, right? When the form just launches, I will just simply create a stack. Okay. Now here's the issue. When I would like to perform an operation, so for example, let's say addition. So there you go. Whenever I click on add, first of all, I would like to check if I just launch the calculator right now and I say 1, and then I hit the plus, okay? Now I would like to know if there has been any operations before. In fact, I would like to know if the buffer is an n or not. Because if this is the first operation, like the first number in my expression, I have to make sure that this number is like not the first one ever, right? Because if there is something else was there, that means that there's need to be an operation to be done probably. So so what I'm gonna do, I'm gonna say if double.isNan, and it's a static function within the double class or the double struct rather, and I'm just gonna say if the buffer is nan, that means I'm just initialize the calculator. I'm just gonna say buffer equals to double.parse, and parse, it takes a string and it will try to parse whatever the string is to the double right now. You have integer.parse, you have float.parse, and so on and so forth. You have actually another one which is safer and better, which is try-parse, which will tell you is this thing has succeeded or not, and it will not throw an exception. So if you give a regular text, this thing will throw an exception. But I will not actually complicate things. I would like to make things really streamlined and really fast. I will leave this for you as an exercise to use try-parse. So here I'm going to have parse. I'm going to parse txt output.text. Okay. Now, once this is done, else if operation stack, but right now, that means right now that if actually this thing was an and, that means just put it in the buffer and you ignore. If, however, that your operation stack is actually empty, or sorry, is not empty, sorry. If it's not empty, that means I have to actually perform an operation. So if this fails, I'll make sure that there's nothing in the operation stack. And if there is something in the operation stack, I will just simply say, okay, please do addition. So I'm going to have say here operation stack dot count. If it doesn't equal to 0, then I'm going to say var operation equals to operation stack dot pop. And right now, whatever in the stack, I will just pop it out. And I will have another function which says evaluate. So I say, please evaluate for me the operation. Now, evaluate doesn't exist yet, so let's actually create it. I hit Alt-Enter, by the way, and just created the thing. Obviously, this is going to be operations. It's of that type. Sorry about that. It has to be like so. Okay, and right now I'm going to have a switch statement over this thing. Okay, first of all, I need to make sure that the text box is not empty, because based on whatever in the text box, I will finish the operation. If the text box is actually empty, that means I've actually done the operation, and I'm pressing the equals, because equal will use the same thing. You'll see what I'm talking about in a minute. So if not string dot is null or empty, txt output dot text. So if that thing is not empty, all what I'm going to do is just simply have a switch statement over the operation which is already being sent. And right now I can say add missing cases. Alt-Enter on the switch, add missing cases, and it will just simply add them for me. And right here I'm going to have, so I will grab whatever in the buffer. Remember, I made sure that this buffer is not an N. Okay, so there's something within the buffer. And if it is addition, just please take whatever in the text box. So double.parse txt output.text. Please take whatever in the text box right now and just add it to the buffer, save it in there. Okay, and we'll do exactly the same thing for subtraction. And we'll do exactly the same thing for multiplication. And exactly the same thing for division. Okay. And then once you are done with that, I'm going to actually display whatever is in the buffer actually on the text box as well. So I'm going to say txt output dot text equals to buffer dot to string. So right now I just simply say take the buffer, whatever number is in there, whatever operation has been done, just put it on the text box. In fact, we have a label which displays the buffer, right? So I'm going to actually use that as well. So lbl buffer dot text equals to buffer dot to string. I know it's repeated, but this could be saved in a variable and blah, 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 but it's actually not that performance hog, so we don't care. All right. Now, one more thing. Actually, whenever I hit an operation, like the plus or minus, I would like actually to clear the operation. Also, if this actually fails, so else if what if actually the count is actually 0? What if something is in there? We need to actually push that operation to the stack. So I'm going to say operations stack dot push operations dot addition in our case here. And I'm going to say here txt output dot clear. So right now you print the plus, just clear the text in order to receive the new number which you would like to add. So let's walk through the logic again. If this is the first time I'm opening the calculator, that means that the buffer is clear. And then I would like to parse whatever is in that text, clear the buffer, parse whatever in that text, put it in the buffer, take the addition sign, push it into the stack. All right. I don't even need to check for this because the buffer is NaN. That means I just simply opened the calculator for the first time right now. And I clear the text output to receive the next number, which I'm going to put, right? If I hit the equal button, I can just simply say evaluate, right? Now, if I hit the addition again, it will just simply go through this thing and also evaluate later. So we need to actually, yeah, so it will evaluate here. Okay. Now let's do this actually for the other buttons. So I'm going to actually double click here, double click here too, and double click here too. So right now I'm handling the click over every one of those guys. I'm going to actually cut that, paste that, and we're going to refactor the code in a bit. Just I'm trying to get here step by step. So obviously this is actually repeating right now almost. So right now this is instead of addition, this is going to be right now subtraction. And this is going to be the same thing, but however it's going to be multiplication, right? I've actually abstracted this evaluate. Right now the evaluation does all the stuff for me, right? And this guy also does division, right? All right, so we push into the stack the division, we clear the text box, we do all that stuff. Now we need equals, actually. We need to finish it as it should be. Now equals, we need to make sure first, it's actually the same as the other buttons, but we need to make sure about one more thing, that the text output is not actually null, or it's not empty. So I'm gonna have here string dot is null or empty, txt output dot text. So if it is not null or empty, then I'm gonna actually check, is anything in the stack, right? So if operation count doesn't equal to 0. If it doesn't equal to 0, that means I have to evaluate whatever is in there, right? Whatever is in the stack and finish the whole thing. So var operation equals to operations stack dot pop, and then I'm going to evaluate, and then I'm going to evaluate the operation. Okay. Once you evaluate the operation, I'm going to say txt output dot text equals to buffer dot to string, and txt, or sorry, lbl buffer dot text is going to equal to buffer dot to string, and operations stack dot clear. And this because you press the equal button. The moment you press equal, I decided that you actually you have cleared, you are done with your calculations. Let's see here. Okay. I'm actually looking at the chat. I forgot that if somebody actually asked a question and maybe I missed it somewhere, I can actually figures things out. Okay. Any questions so far, by the way? People?
No.
No questions. No questions.
All right. Okay. Now, obviously, when you look at this code is repeating. This actually happening regardless of the regardless of what you do, right? So if addition, it does exactly the same thing, actually, right? It never changes. So this, I can actually grab all this, Alt Enter, extract method, and this method is going to be perform operation. And right now, this guy, I can actually move it a little bit upwards here. And I can actually take this line, substitute it with this. Because imagine that you need to change any logic in here, right? Which was repeating. You have to do it like 4 times. And since all of them are identical, you don't need to do anything. Just simply say, call this every time you click on a button there. Okay. Now let's hope that I didn't miss anything, because there was a lot of code has been written without testing, which is a very bad idea. A recipe for catastrophe, but hey, let's see. So 1 plus 2 plus, right now you see the buffer has 3. 6 equals to 9. Right now the result has been finalized. I can say multiplied by 8 equals to 72 minus 2 is going to equal to 70, right? So right now I'm actually following this kind of chaining just these calculations all together. Okay. Now, obviously, you need to protect yourself from the crazy stuff like dividing by 0, having multiple dots. You can't forbid yourself from doing this, obviously, because if you do that right now, the whole thing will not work. Actually, the easy fix for this is this. You can grab this and you can say read only. There you go. So read only is true. right now, nobody can edit this. So if you try to click here, you cannot do anything in there. However, right now, the interesting part here, what you could do also is that you could allow only numbers to enter, I think. But I think you need there is another one. There's numeric up, down. I cannot remember anymore right now. I think there was a property for this. No, probably I need to remember. I actually cannot remember anymore, but there was one way to actually like forbid anything other than numbers. You could actually even like do it on text, on input changed here, that you can actually forbid this forbid people from adding characters and only numbers, and a dot can pass through. I just cannot remember anymore, to be honest. It's definitely I think it's this one. I can't remember. Well, I need to check it out probably offline, and then if I remember, I will just prompt. Yeah, probably I need to check out set mask. There we go. So here I can actually like say that this is the data which only can be entered. The problem is I just cannot remember right now. This is a 5-digit. I can have a custom one, I think. Yeah, you can have like phone numbers, like making this that nobody can input anything else. So this is actually the input mask. Probably I need to figure out the one way for inputting only doubles, probably. But just cannot remember where it was. I haven't used this since a very long time. So you might actually even have a look at this. But this is actually very good control in order for you not to verify too much input live. You have just a control for that, and you put the rule for it, and it will just work. In any case, let me just minimize this right now. I will actually like create another project, and I would like to carry on with the class. There is one more thing. I'm going to create a .NET Framework console app because I would like to talk to you about a for each loop, because Dennis has already mentioned it in the classroom, and I need to stress on a couple of things there. The code for this guy is going to be sent to you right away in a Jiffy. So let me take this. Where's my Solution Explorer? And I will just simply shut this guy down. Give me a minute. So this is going to be so. And I'm going to send it to you right. Where is the chat? Can we implement operation square root and power? Yeah, you can. Obviously, you can. Oh, how can we implement operation square root and power? We'll just simply add the operations, actually. So you need to like, oh boy, I actually closed this, but let me actually send you this thing. first. Sorry, I just noticed your question right now, to be honest. Apologies. Let me open this again. So probably gonna need to add more of these guys. Where is... Oh, sorry, I opened the wrong solution. That's not this one. I need the fit calculator, which is this one. Now, obviously, you're gonna need a button for example, for the power or a square root. And once you press on that button, you will actually have to perform it immediately. Like, so for example, in fact, there's no need to add an operation. So for example, if you have a power, I mean, I'm actually like saying this off top of my head. So for example, you press the power handler button, which has an object sender and even args E, for example, right? And let's say you press that power button. So you will do your checks, right? You will do your checks if the buffer is there and everything. But then you have to immediately say whatever is in that text box, for example. You say txt output.text equals to... sorry, you need first to grab it. So var buffer. And right now you're going to need to pop the operation actually. So plus equals or something like that. Let me think, hang on. Yeah, actually going to pop twice, in fact. I mean, I'm like right now trying to think of this thing. Yeah, you're going to need probably to pop twice. So you're going to have to one operation to push in the stack. And this is a kind of a special operation, like a square root or something like that. So yeah, actually I would actually have two stacks of these guys, because addition, subtraction, and multiplications and division requires a second parameter. However, if you say square root of whatever number you input, then you need to calculate it right on the spot, because anyway it's going to be converted into an actual number that you can like use with addition, subtraction, multiplication, and division. Does this make any sense? So it's going to be the same like these guys. Sorry, like these guys, except probably it's going to have its own stack. So you're going to have to check, is that stack of these special operations are empty or not? Okay. I will assume that you are saying okay, because you are not responding to chat. Anyway, I already have sent you the code. I advise you to look at it, try to fix bugs, try to make things better in there. Now, honestly, I'm not gonna give a break here, because today's class was doing exactly what Dennis has done, or what has shown you already with the registration form and adding people to the registration form with validations and stuff. It was actually identical. So what happened on the class was, I came in, I showed them, I talked about the for each, which I'm going to talk about in a minute. And then I gave them the task to actually do exactly what Dennis has done. And it was actually not that straightforward for people, apparently, because people are not trying at home. So if you are not trying these stuff, which Dennis is already showing, it's actually a really problem. So I really advise you to try these stuff at home, because people are really struggling. And we are actually with the Dennis's, for example, what he has shown last time with the two forms and registration and keeping in memory DB, this is actually right now closer. You are right now closer to the exam format of how to handle like inputs and stuff, and handling data and parsing things, creating objects, saving stuff to databases, and so on and so forth. So and if you get stuck and you don't know how to fix a problem, please you know, contact me. Feel free to contact me on MS Teams or email, and I'm happy to jump on a screen shared call and I'll help you out, like I am helping out other people in the classroom. So Now let's talk about for each loop. Now for each loop is actually quite interesting loop in terms of how it works. And there's a very important concept that you need to understand. There's a difference between something which is called iterators and enumerators. Okay. Now, iterators, you already have seen it in C++, right? However, you haven't seen enumerators. Now, I think there is no iterators in C#. I mean, because for each is actually a enumerator. Now, what is the difference, right? Now, if you have a list of integers, so var lst equals to new list of ints, and you have 1, 2, 3, 4, 5, 6. And then you would like to for loop over that. What you usually do, you say, okay, for int I length, which is going to be lst.count. Then you say console.writeLine, or do whatever operation. LST of I. Come on, LST of I. Okay, so I hit Control F5. This thing runs, everybody's happy. Now, if you actually use for each, however, things are a little bit different. For each var item, which is going to be int item actually, in LST, then you can actually do exactly the same thing. It will in fact give you also the same exact effect. However, one of the things which you are not allowed to do is this. You cannot say item equals to 10. However, in the for loop, you can say, come on, thank you. And then you can say item equals, LST of I equals to 10. You can actually do that. Now, why, right? This is the question. And this is a very, very important thing to understand about for each loops. For each loops are what we call enumerators. And in the enumerator, you cannot modify a list. So this list, when you are for eaching over them, for every item in there, you are pointing to you are getting the value of every item in the list. You are not allowed to modify it. And this is because for each loop works on every class that implements the IEnumerator interface, which is very important. Now, IEnumerator interface, if you have a class person and it implements IEnumerator, it will actually, you can actually say for each over that person class because you implemented the IEnumerator interface. If any class that doesn't implement the IEnumerator interface, it will not work. In C#, I think all collections, list, stack, queues, and so on and so forth, arrays, I think, array list, I think it's so called, all of them, they implement the IEnumerator interface, meaning they can for each over them. Now, what happens? Why? But again, still, the question is like, why I cannot modify it, isn't it? Like, what the heck is happening in there? So the best thing to understand this is that you look at this decompiled. So we can actually Control-Shift-B, and I need to find, let's see, I need to find ILSpy so I can decompile this. So I hope that I have it somewhere here. There we go, ILSpy. Okay, so let me remove this thing and let me remove that thing too. And let's actually find this thing. So I'm going to go ahead here, open in File Explorer, and I'm going to go in there, debug, and I'll just simply drag it. I dragged it right here. So if we look at the code, yeah, I need to tell it not to decompile for each correctly. So there you go. I just simply say detect for each statement. I will just simply remove it for now. So right now, this is exactly how it looks like in the compile, like how the compiler translates your code. Okay, whenever it sees a for each statement, it grabs the enumerator object, coming from the system.collection.list. If you look at list, system dot collections dot generic, and you have the stack. You see, where is list? Oh, linked list, queues, sorted queue, dictionary, debug. What am I actually not seeing things right now? Where is the list? Wow, weird. Okay, I'll grab linked list in this case. Who cares? Now, linked list implements as well the IEnumerator interface. I don't know why I'm not seeing it, which is kind of weird, to be honest. Could it be thrown somewhere else? Yeah, apparently, like system.core is somewhere. That's fascinating. Yeah, I'm not gonna dig deep there. So you have it there. It's actually like, imagine that this is actually also like a list instead of a linked list. It will implement the IEnumerator or IEnumerable also. IEnumerator also interface there. It has the enumerator struct inside, and it has to implement move next. One of the methods, actually get enumerator. This is one of the things. Where is move next? Also somewhere there. Here's the current. You see this? This current, which is, I'm going to show you in a minute, it's just only a getter, which is here. You see? Current, it's just a getter, nothing more. You're grabbing the whatever the current is, and the current, in fact, is just a get. You cannot set that thing, right? And this is why it throws you an error. And this is why people are trying to modify stuff in the for each loop, and it just doesn't work. It will never work just because of this. Okay? So that's why it's called an enumerator. You just simply read only and you do things. However, there's a small trick that you might see and it might confuse you. Let's assume that you have a person class with an ID and a name, which is fine. Okay. Don't you love AI when explaining things? It just, finishes stuff really quickly. And if I have, for example, var lst equals to new list of person, LST, okay, let be persons. Okay. And I don't care about what is inside because I would like to drive a point across here. So if you're actually for each every item, var, let it be var because I have divided this as an integer. I should have said person, right, for every person in person, but this is going to be var just to make it faster. Here you can say, here again, you cannot say this, right? Because again, you are violating the rule. The current you cannot modify. However, you can say this, dot ID equals to 1, 2, 3 item dot name equals to something, right? And this is actually allowed. So you're allowed to modify the properties of a class, or sorry, of an object, but you are not allowed to modify the object itself. The object itself is read only. You cannot do anything to it. And this is why for each works in the way it works. And this is why it's called an enumerator. An iterator, let's say like in C, and C++, you are allowed to modify the object. You can actually substitute that object with something else. And this is why it's called an iterator. Does this make any sense?
Yes.
Okay. So right now I've covered. I've already solved, like I've solved the part regarding the problem of the calculator for some people. I've also displayed what a for each is about. The rest of the class, again, I'm repeating, like the rest of the class was just having this practice, live practice. Again, I advise you to try this at home. And if you get stuck, please let me know, because again, I mean, whatever I'm going to show is going to be exactly identical to Dennis's work, which is already published on YouTube. So I'm covering right now the stuff which hasn't been explained thoroughly already. So yeah, let me know if you have any problems, and I will actually stop recording right there.